Okay, so welcome back. We're going to talk about systems today, which is one or more equations or inequalities. Okay, and remember the whole point of solving a system is to find where those two equations cross, right? And what solution works for both of them. So if I look here, I have the point 4, 6. So my solution to this system would be the point 4, 6, and our answer should always be an ordered pair. Sometimes we do know that there is no solution or infinitely many solutions, but we'll come to that in a few minutes. Let's talk about the different ways we can solve a system because we don't always want to graph them, right? Especially if our point is not a perfect 4, 6. Maybe it's 4.23, 6.53, right? No one wants to try and figure that out from a graph, and it's not as exact. So remember, you can choose any of these ways to solve it. You don't have to do substitution every time. You don't have to do elimination every time. You can mix them or you can choose one. It doesn't matter. So substitution, remember, we need to have a variable by itself. Y is in fact by itself. So I'm going to place negative 2x plus 3 into y of this equation. So I have the x from this part plus, now I'm going to put this in parentheses, negative 2x plus 3, so that was the y part, equals negative 1. Okay, and again, I put this in parentheses to check and make sure there's nothing outside of those parentheses I need to worry about. Like if there was a 2 in front of that y, then I would have had to bring a 2 down here, okay, and then distribute that 2 accordingly. Okay, so what I'm going to do is pick another color here. There's nothing outside the parentheses, so I can just combine like terms. Negative 2x plus x is negative x, plus 3 comes down, equals negative 1. We're going to solve for x by subtracting 3. We're going to have negative x equals negative 4. So we're going to divide by negative 1. So therefore x equals 4. Now we're not done. We just know what x is. So what I'm going to do is I'm going to plug x back into one of my equations. Now since y is already solved for in the first one, I'm going to plug it into that one. But I could have very easily plugged it into the second one. So I'm going to have y equals negative 2 times 4 plus 3. Negative 2 times 4 is negative 8. Plus 3, which would be negative 5. So I end up with the answer for negative 5. Remember, we always put in our answer as an ordered pair, and it is in fact going to be x comma y in parentheses. Sorry, I have a little tickle in my throat. I had to take a drink. Now elimination is where we try to eliminate a variable. And I'll actually go back, and if you need to pause this and kind of catch up writing, if you are writing these down, you can go ahead and do so. Elimination is where we try to eliminate a variable, okay? Now I'm going to erase this just so it's kind of out of my way, okay? So we can choose to get rid of x or y. I'll choose to get rid of x this time. Remember, we always want to choose something where it's easy to manipulate the variable. We want to try and not have to multiply both of them. So since I can multiply this top one by negative 2, then the x's will cancel out. So I'm going to distribute the negative 2 to every piece, okay? Not just part of it. So that's going to become negative 2x minus 2y equals negative 24. We have to distribute that 12 with the negative 2, okay? Otherwise we're going to have issues. And then I'm just going to rewrite the bottom equation because nothing changed. And then we're going to add them together. And we can add them together because one x is positive and one x is negative and something will cancel out. Otherwise you need to go back and multiply by a negative. So I'm going to add those together. That cancels to be 0. Negative 2y plus 5y is 3y. And then negative 24 plus 27 would give me a positive 3. We're going to divide by 3 to solve for y. So I get y equals 1. We're halfway there. Again, we're going to plug that back into an equation. Again, I'm going to choose my first one just because there's less stuff in there. There's not the 2 and the 5 involved. So we're going to have x plus 1 equals 12. We're going to subtract 1 from both sides, so x has to equal 11. So again, we're going to write that number as an ordered pair, 11, 1. Okay. Remember, special cases, we could have no solution or infinitely many solutions. No solution is when the lines are parallel to each other. And infinitely many solution is when the line is exactly on top of itself. Okay. So remember, if we get no solution, that's when we get something like 0 equals 5. Okay. That's never going to be true. Infinitely many solutions is when I get something like 0 equals 0 or 5 equals 5. That is a true statement every time. So let's go ahead and solve this one. Again, we could do substitution or elimination. I'm going to do substitution just because it's quick. So that y is really 3x minus 7, so we're going to have 3x minus 7 equals 3x plus 2. Again, always move your variables first. That'll just help you a lot. So we're going to get negative 7 because this cancels, and this also cancels, equals 2. Negative 7 will never equal 2, so this would be no solution. Okay, if I got negative 7 equals negative 7, that would be infinitely many solution, or all real solutions, which some of you really like to shorthand with a double R. Okay. If you're in Math 8, this is where you stop. If you are in